Yesterday, we learned about the negative exponents. What do negative exponents do for us? What kind of numbers do negative exponents create? You have to peek back at what we said yesterday. It asked us that question. Do negative exponents get us negative numbers? No. Negative exponents get us what kind of numbers? Oh, positive numbers. But when we have a negative exponent, what is the number going to look like? So if you don't remember, you can go back on yesterday's notes. I think it was the third question down. It asked about what kind of numbers do negative exponents make? Reciprocal, yes, which means that makes fractions, right? Negative exponents will create fractions. So this negative exponent should really be a reciprocal, right? Which means it be in the bottom of a fraction. So the first thing I'm going to do is rewrite this as 6 to the 5th. Highlight the whole thing over 6 to the 3rd, because that negative exponent really meant he was a fraction. All right? Then we're going to spread it out. That's the giant one part. So what's the top going to be spread out to look like? What's the bottom going to be spread out to look like? Spread it out. What's the top going to spread out to look like? Let's start with that. This is, where are 3's coming from? Oh, okay. 6, shift 8 times 6, right? 5 of them, because that said 6 to the 5, right? I want these to be red. Now, I need to make this into a fraction, so I have to highlight the whole thing and then hit the divide, which is the slash. What's the bottom going to look like? Yep, 6 times 6 times 6. Where am I getting that dot from? Where's the dot at? How do we get that dot? Shift 8. How do we get the exponent? Where's the exponent at? Shift 6. Okay. So now we're going to do like we've been doing. We're making the big one. So we're crossing off things that would equal 1 because there's 1 on the top and 1 on the bottom. So 6 divided by 6, there's a 1. Then there's another 6 divided by 6, there's a 1. And another 6 divided by 6, there's a 1. Those were all 1s, right? Why does that look like it's black? Okay, so what's left? What's left? Six times 6 is what's left, yes. Okay, so 6 times 6 is left. And we need to simplify that into exponent form. So what would that be? Yep, 6 to the 2nd power. Okay, so we're going to repeat this process for all the other ones too. So step 1, rewrite it as a fraction. Which piece moves? Whenever we're looking at numbers and we're looking at exponents, which exponents move? Which kind of exponents move? Positives or negatives? Negatives. So we're always going to rewrite moving the negative to the bottom where it should have been all along. Okay? So how would I rewrite this particular problem? If I'm going to rewrite it as a fraction, what's that fraction going to look like? Knowing that negative exponent ones move to the bottom. So what are we going to say this guy's fraction is? We're not spreading out yet. We're rewriting the fraction first. Yes. W to the 5th, highlight, divided by W to the 2nd. Yes. Remember, once it moves, it loses the negative. Now, Brian, we're spreading out. So the top is going to look like what Brian said. 5 W's, right? W, 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 W. But what's the bottom going to look like? Highlight it off, divide by. What's the bottom going to look like? Spread out the bottom. What's it going to look like? W times W, yes. And then we're going to go get our line and we're going to cross out the stuff that make 1. And it's a 1 because there's something on the top that's identical to something on the bottom. So 1 W from the top, 1 W from the bottom, another W from the top, another W from the bottom. You have to stop once there's not a match. You have to have 1 on the top and 1 on the bottom. So what's left? What's left? And Lily, it's not over -2, it's over 2. Once it moves, the negative goes away. So what's left? Yes, W times W times W. And we would write that in the simplest form with an exponent of W to the 3rd power. Okay. Final answer. Final answer. Not difficult, not scary. Okay. How am I going to rewrite this one? Which piece moves to the bottom? When we're moving things, what is the piece that always moves? The one with the negative exponent. Yeah. So 10 to the 5th was positive, and it's being divided by 10 to the 4th, which was the negative. Once it moves, the negative sign goes away. The negative sign is the ticket for the trip. Think about it that way. You have to pay for the trip somehow. So he paid for it with his negative sign. Okay, let's spread this out. What would this be? Mm-hmm. 5 10s in a row. 10 times 10 times 10 times 10 times 10. All of this highlighted and being divided by what? Yes. 10 times 10 times 10 times 10, 4 of them. Okay, so 1, 2, 3. Okay, crossing out the ones that match. So a 10 on the top for the 10 on the bottom, but I need to have the line, not the box. I keep forgetting. And then it erased the part I didn't want it to. What the? What? I want to get rid of the dot and the box. Sometimes this thing, I'll just start over. There, it's back. Can I go back one more? Would it give me back my, no. All right, forget it. We're just going to start over. Love-hate relationship with technology. Okay, once we've crossed out everything, what's left? Because we're going to match a top with a bottom, right? Match a top with a bottom. Now remember, I want this written in exponent form. Oh, I keep picking the wrong eraser. Oh, I want to pick this one. Okay, thank you. I fixed it now. So I don't get rid of everything. Okay, so what's left? What's left? Now, I want this in simplified exponent form. So what am I going to write? 10 to the first. Yes, because we remember that when we see one of them, the exponent is 1. Just like when we see one variable, it's 1x. When we see one number, it's exponent 1. Okay, question about those before we move on to the next thing. So in this one, they had a positive with a negative, and they were side by side, right? All right. Now, who knows what the shortcut way would have been? Because they're side by side, what would the shortcut version have been? How could we have written this another way? Instead of having to spread it out, what other math could we have done? Yes, we could have done the add the exponent rule because they're side by side. So I'm putting this one in green, please. Change your color to green. So this would be 6 to the, don't forget to put the to the, 5 plus -3, which gets us what? What is 5 plus -3? 6 to the, what's a 5 plus a -3? 2. Now, those pluses and minuses have to happen in the exponent level. So let's do this one. We're in green because we're doing an alternate method. All right, how would we rewrite this one? W to the what? So we're doing this one just like we did the part A. So we're doing the green version of this one. W to the, what would I put in the sky? Just like I put over here. How would I write it? Yes, but no. 5 plus, because we're adding, -2. I understand that 5 plus -2 is the same thing as 5 minus 2. The problem is I want to keep trapped in my head that I'm adding those exponents, okay? And that's why it's W to the 3rd. Now, we didn't do it originally this way because they specifically asked us to make a fraction and do the giant 1 stuff, which is expand. But this is the other way to do it. If they're not specifically asking you for a way, you could use this way. How would we do this one? Part C. 10 to the what? Remember, we're adding the exponents. What are we going to write? Write them like you see them. So what would we say? Notice we've done them all. The exponents go in the same sequence as the original problem. So what would this one sequence be? Yep, -4 plus 5. Arrow off. That gets us 10 to the first power. All right. So they had specifically asked us to do the fraction stuff, but I wanted you to see, remember, adding exponents works too. Okay. Now we're going to think in reverse. Okay. If a negative exponent can create a fraction, then a fraction can be written as a negative exponent. So simplify the expressions. Write your answer in two different forms, as a fraction and as an expression with a negative exponent. So when we are top to bottom, side by side, what did we do with our exponents? Added. So top to bottom, what are we going to do with our exponents? Because side by side, that's multiply, right? This is multiply, right? What does a fraction really mean in math operations? Divide. So if multiply, we add the exponents, then divide means we must do what? Subtract the exponents, and we talked about that yesterday. So we are going to go subtract our exponents. Our exponents say 6 to the 3 minus 5. Right? So then we solve. What would we get? 6 to the what? Six to the what? 3 minus 5 is 2? No, -2. So we've handled there, write it in a negative exponent form, so we can highlight that one. There's one of my answers, but they also wanted the final answer as a fraction. So how would I write this 6 to the -2 as a fraction? Remember, the negative exponent says reciprocal the number. What's the reciprocal of 6? If I set up 6 as a fraction, what is it going to look like? Yes, it's going to be a 1 over 6 to the 2. Remember, once we move it, it loses its negative. Okay? No. All right. I took it away. 1 over 6 to the second power. So we got to go do the next one. How would I show my work for B? Copy what we did for this one. How would we do the next one? Same way. So what's my first step of the work going to say? What's my first piece of the work going to say? Look at how we did A. Do the same thing with B. It doesn't matter that B has letters. Yeah. m to the 5 minus 6. Because it's division, we subtract the exponents. Then we simplify. What does this simplify to? Solve out the exponent. What would it be? -1. Okay, so we got our negative exponent version done. Now we have to do our fraction version. How would we rewrite this as a fraction? Yeah, 1 over n to the first is the exponent form, but in the long run, 1 over m. Okay, these mean the same thing. I want you to get in the habit of writing both. Okay, they mean the same thing. I want you in the habit of writing both. Okay, last one, and then we get to start our assignment. So what are we going to say? What's our first step? Going to say 10 to the what? No, I need the whole exponent. Look at how we've done all the other ones. What's the first step? 10 to the 2 minus 5. Okay. Then we solve that exponent to get what? 10 to the what? -3. There's our first piece that we get to highlight because they said as a negative exponent and a fraction. Now we have to rewrite this as a fraction form because we haven't done the fraction form. What's the fraction form? Good. 1 over 10 to the third. Yes. Okay. So remember, when we are multiplying with the same base, we add exponents. When we're dividing by the same base, we subtract exponents. If it's a negative exponent, it's really a fraction in disguise, right? Okay, any questions about this? Save it, turn it in. Let's get working on the assignment. Save it, turn it in Kami, turn it in the Google Classroom.